Hi everyone, welcome to my YouTube channel. Today I will explain you all the shader nodes in Blender 2.9. First of all, you must subscribe, share and like. In this video you will learn input nodes. Let's start. The first one is ambient occlusion. The ambient occlusion shader computes how much the hemisphere above the shading point is occluded. This can be used for procedural texturing, for example to add weathering effects to corners only. For cycles, this is an expensive shader and can slow down render significantly. If render time is a concern, using pointiness from the geometry node or baking ambient occlusion will render faster. This node is unsupported on OptiX GPU rendering. Inputs: color, tint for AO output color, distance cycles only, distance up to which other objects are considered to occlude the shading point, normal. Normal used for ambient occlusion. If nothing is connected, the default shading normal is used. Properties: samples cycles only. Number of samples to use for ray traced ambient occlusion sampling. Keep as low as possible for optimal performance. Inside cycles only. Detect convex rather than concave shapes, by computing occlusion inside mesh. Only local cycles only. Only detect occlusion from the object itself, and not others. Outputs: color, ambient occlusion with color tint, AO, ambient occlusion factor without color tint. Example: the second one is attribute node. The attribute node allows you to retrieve attributes attached to an object or mesh. Inputs: this node has no inputs. Properties: name, name of the attribute. Type, specifies the type of the attribute. Geometry, the attribute is associated with the geometry of the object, and its value varies from vertex to vertex, or within the volume of the object. Most geometry attributes are directly accessible through the various input nodes, except for these. Vertex color layers. These can be retrieved by their names. Density, gives a scalar defining the density of any smoke inside the fluid domain. Color, gives the color of the smoke inside the fluid domain. The color and vector outputs are the same. The factor output is an average of the channels. Temperature, gives a scalar defining the temperature of the volume. Values in the range 0 to 1 map to 0 to 1000 Kelvin. This may be used to render physically based fire with the blackbody or principled volume shaders. All three outputs are the same. Flame, gives a scalar defining the density of any fire inside the fluid domain. All three outputs are the same. Ocean foam, gives a scalar defining where foam might appear when using an ocean modifier. This depends on the name you give this property. For a full list of options, see this thread on the Blender Stack Exchange. Object, the attribute name specifies a custom property name, or an RNA path to a built-in property, like the single property driver variables. The values of attributes of this type are defined once per object. The name or path is looked up first in the object data block, followed by the mesh data block if not found. Custom properties have priority over built-in ones. The property value must be an integer, float, or a vector of 1 to 4 floats. Properties of other types are ignored. If a suitable property is not found, all sockets of the node, including alpha, output 0. The color attribute will output the value of the color field in the viewport display panel of the object, unless overridden by a custom property. Instancer, similar to object, but the attribute is looked up in the instancer particle system settings, followed by the instancer object. If the current object is not instanced, or the property is not found, it falls back to the object mode. Outputs: color, RGB color interpolated from the attribute. Vector, XYZ vector interpolated from the attribute. Factor, scalar value interpolated from the attribute. Alpha, alpha channel of the attribute, when available. If the attribute has no alpha channel, generally defaults to 1. Instancer. Similar to object, but the attribute is looked up in the instancer particle system settings, followed by the instancer object. If the current object is not instanced, or the property is not found, it falls back to the object mode. Outputs. Color. RGB color interpolated from the attribute. Vector. XYZ vector interpolated from the attribute. Factor. Scalar value interpolated from the attribute. Alpha. Alpha channel of the attribute, when available. If the attribute has no alpha channel, generally defaults to 1. The third one is bevel node. Cycles only. The bevel shader node can be used for rendering rounded corners. Like bump mapping, this does not modify the actual geometry, only the shading is affected. Slight rounding on edges helps to capture specular highlights that you would also see in the real world. Note that this is a very expensive shader, and may slow down renders by 20% even if there is a lot of other complexity in the scene. For that reason, we suggest to mainly use this for baking or still frame renders where render time is not as much of an issue. The bevel modifier is a faster option when it works, but sometimes fails on complex or messy geometry. This node is unsupported on OptiX GPU rendering. Inputs. Radius. Width of the bevel effect on edges. Normal. Normal to apply bevel on top of, to be combined with a bump node for example. Properties. Samples. Number of samples to take for each shader evaluation. More samples give more accurate results, but are also slower to render. The default value of 4 works well for most cases, with any noise resolved by using more AA samples. Outputs. Normal. Standard normal output. Example. Camera data node. The camera data node is used to get information about the position of the object relative to the camera. This could be used for example to change the shading of objects further away from the camera, or make custom fog effects. Inputs. This node has no inputs. Properties. This node has no properties. Outputs. View vector. A camera space vector from the camera to the shading point. View Z depth. The distance each pixel is away from the camera. View distance. Distance from the camera to the shading point. Fresnel or dielectric Fresnel node. The Fresnel or dielectric Fresnel node computes how much light is reflected off a layer, where the rest will be refracted through the layer. The resulting weight can be used for layering shaders with the mixed shader node. It is dependent on the angle between the surface normal and the viewing direction. The most common use is to mix between two BSDFs using it as a blending factor in a mixed shader node. For a simple glass material you would mix between a glossy refraction and glossy reflection. At grazing angles more light will be reflected than refracted as happens in reality. For a two-layered material with a diffuse base and a glossy coating, you can use the same setup, mixing between a diffuse and glossy BSDF. By using the Fresnel as the blending factor you are specifying that any light which is refracted through the glossy coating layer would hit the diffuse base and be reflected off that. Inputs. IOR. Index of refraction, IOR, of the material being entered. Normal. Input meant for plugging in bump or normal maps which will affect the output. Properties. This node has no properties. Outputs. Factor. Fresnel weight, indicating the probability with which light will reflect off the layer rather than passing through. Geometry node. The geometry node gives geometric information about the current shading point. All vector coordinates are in world space. For volume shaders, only the position and incoming vector are available. Inputs. This node has no inputs. Properties. This node has no properties. Outputs. Position. Position of the shading point. Normal. Shading normal at the surface, includes smooth normals and bump mapping. Tangent. Tangent at the surface. True normal. Geometry or flat normal of the surface. Incoming. Vector pointing towards the point the shading point is being viewed from. Parametric. Parametric coordinates of the shading point on the surface. To area lights it outputs its UV coordinates in planar mapping and in spherical coordinates to point lights. Back-facing. 1.0 if the face is being viewed from the back side, 0.0 for the front side. Pointiness cycles only. An approximation of the curvature of the mesh per vertex. Lighter values indicate convex angles, darker values indicate concave angles. It allows you to do effects like dirt maps and wear-off effects. Random per island cycles only. A random value for each connected component, island, of the mesh. It is useful to add variations to meshes composed of separated units like tree leaves, wood planks, or curves of multiple splines. Hair Info Node. The Hair Info node gives access to hair information. Inputs. This node has no inputs. Properties. This node has no properties. Outputs. Is strand. Returns 1 when the shader is acting on a strand, otherwise 0. Intercept. The point along the strand where the ray hits the strand, 1 at the tip and 0 at the root. Thickness. The thickness of the strand at the point where the ray hits the strand. Tangent normal. Tangent normal of the strand. Random. A random per hair value in the range from 0 to 1. It can for example be used in combination with a color ramp, to randomize the hair color. Layer weight node. The layer weight node outputs a weight typically used for layering shaders with the mix shader node. Inputs. Blend. Bias the output towards all 0 or all 1. Useful for uneven mixing of shaders. Normal. Input meant for plugging in bump or normal maps which will affect the output. Properties. This node has no properties. Outputs. Fresnel. Dielectric Fresnel weight, useful for example for layering diffuse and glossy shaders to create a plastic material. This is like the Fresnel node, except that the input of this node is in the often more convenient 0.0 to 1.0 range. Facing. Weight that blends from the first to the second shader as the surface goes from facing the viewer to viewing it at a grazing angle. Light path node. The light path node is used to find out for which kind of incoming ray the shader is being executed, particularly useful for non-physically based tricks. More information about the meaning of each type is in the light paths documentation. Inputs. This node has no inputs. Properties. This node has no properties. Outputs. Is camera ray. 1.0 if shading is executed for a camera ray, otherwise 0.0. Is shadow ray. 1.0 if shading is executed for a shadow ray, otherwise 0.0. Is diffuse ray. 1.0 if shading is executed for a diffuse ray, otherwise 0.0. Is glossy ray. 1.0 if shading is executed for a glossy ray, otherwise 0.0. Is singular ray cycles only. 1.0 if shading is executed for a singular ray, otherwise 0.0. Is reflection ray cycles only. 1.0 if shading is executed for a reflection ray, otherwise 0.0. Is transmission ray cycles only. 1.0 if shading is executed for a transmission ray, otherwise 0.0. Ray length cycles only. Distance traveled by the light ray from the last bounce or camera. Ray depth. Number of times the ray has been reflected or transmitted on interaction with a surface. Passing through a transparent shader does not count as a normal bounce. Diffuse depth cycles only. Number of times the ray has gone through diffuse reflection or transmission. Glossy depth cycles only. Number of times the ray has gone through glossy reflection or transmission. Transparent depth cycles only. Returns the number of transparent surfaces passed through. Transmission depth cycles only. Replace a transmission light path after X bounces with another shader, e.g. a diffuse one. This can be used to avoid black surfaces, due to low amount of max bounces. Object Info Node. The Object Info node gives information about the object instance. This can be useful to give some variation to a single material assigned to multiple instances, either manually controlled through the object index, based on the object location, or randomized for each instance. For example, a noise texture can give random colors, or a color ramp can give a range of colors to be randomly picked from. Inputs. This node has no inputs. Properties. This node has no properties. Outputs. Location. Location of the object in world space. Color. Object color, same as color in the properties object properties viewport display. Object index. Object pass index, same as pass index in the properties object properties relations. Material index. Material pass index, same as pass index in the properties material settings. Random. Random number unique to a single object instance. Note that this node only works for material shading nodes, it does nothing for light and world shading nodes. Example. Particle Info Node. Cycles only. The Particle Info node can be used in the Material Node tree for objects that are used as the instancing objects, when you use Object or Group Render mode of a particle system. This node gives access to the data of the particle that spawned the object instance. It can be useful to give some variation to a single material assigned to multiple instances of instancing object. This node currently only supports parent particles. Info from child particles is not available. Inputs. This node has no inputs. Properties. This node has no properties. Outputs. Index. Index number of the particle, from 0 to number of particles. Random. A random per particle value in the range from 0 to 1. It can for example be used in combination with a color ramp, to randomize the particle color. Age. Age of the particle in frames. Lifetime. Total lifespan of the particle in frames. Location. Location of the particle. Size. Size of the particle. Velocity. Velocity of the particle. Angular velocity. Angular velocity of the particle. RGB node. Inputs. This node has no input sockets. Properties. The RGB node uses the color picker widget. Outputs. Color/RGBA. A single RGBA color value. Tangent node. The tangent node generates a tangent direction for the anisotropic BSDF. Inputs. This node has no inputs. Properties. Direction type. The tangent direction can be derived from a cylindrical projection around the X, Y, or Z axis, radial, or from a manually created UV map for full control. Outputs. Tangent. The tangent direction vector. Texture coordinate node. The texture coordinate node is commonly used for the coordinates of textures, typically used as inputs for the vector input for texture nodes. Inputs. This node has no inputs. Properties. Object. Specific object to use for object space coordinates. This only affects the object output. From instance or cycles only. If the object is generated by instancing from vertices or faces, use texture coordinates from instancer. This only affects the generated and UV outputs. From instancer only works with the UV output when the object is instanced, either from particles or from faces. Outputs. Generated. Automatically generated texture coordinates from the vertex positions of the mesh without deformation, keeping them sticking to the surface under animation. Range from 0.0 to 1.0 over the bounding box of the undeformed mesh. See texture spaces for more information. Normal. Object space normal, for texturing objects with the texture staying fixed on the object as it transformed. The normal output can be used on point and spot lights. The coordinates will take the rotation of the light into account. UV. UV texture coordinates from the active render UV map. See UV mapping for more information. In order to select UV map other than the active map, you must use the UV map node. Object. Uses an object as a source for coordinates. Often used with an empty, this is an easy way to place a small image at a given point on the object. This object can also be animated, to move a texture around or through a surface. Camera. Position coordinate in camera space. Window. Location of shading point on the screen, ranging from 0.0 to 1.0 from the left to right side and bottom to top of the render. This is well suited for blending two objects. Reflection. Uses the direction of the reflection vector as coordinates. This is useful for adding reflection maps. You will need this input when using environment maps. UV map node. The UV map node is used to retrieve specific UV maps. Unlike the texture coordinate node, which only provides the active UV map, this node can retrieve any UV map belonging to the object using the material. Inputs. This node has no inputs. Properties. From instance or cycles only. See the from instance or option of the texture coordinate node. UV map. UV map to use. Outputs. UV. UV mapping coordinates from the specified UV map. Value node. The value node is a simple node to input numerical values to other nodes in the tree. Inputs. This node has no input sockets. Properties. Single numerical value, floating point. Outputs. Value. The value set in the node properties. Example. In the example below, the value node is used to control multiple values at once. This makes the node a useful organizational tool. From this you can also make different values proportional to each other by adding a math node in between the different links. Vertex color node. The vertex color node provides vertex colors as well as their alpha value. Inputs. This node has no inputs. Properties. Vertex color. The target vertex color. The listed vertex colors are those of the mesh of the active object. If the active object has no mesh, a warning will be displayed. If the property is marked in red, it means the vertex color is not available in the mesh of the active object, but it may be available in other meshes of objects that share this material. Outputs. Color. Vertex color. Alpha. Alpha value. Volume info node. The volume info node provides information about smoke domains. Inputs. This node has no inputs. Properties. This node has no properties. Outputs. Color. Smoke color. Density. Smoke density. Flame. Fire density. Temperature. Temperature of the fire. Values in the range 0, 1 linearly maps to temperatures in the range 0, is of an object as it appears to cycles. As meshes are triangulated before being processed by cycles, topology will always appear triangulated when viewed with the wireframe node. Inputs. This node has no inputs. Properties. Pixel size. When enabled, the size of edge lines is set in screen space. Size. Thickness of the edge lines. Outputs. Factor. Black and white mask showing white lines representing edges according to the object's topology. Examples. Wireframe node. The wireframe node is used to retrieve the edges of an object as it appears to cycles. As meshes are triangulated before being processed by cycles, topology will always appear triangulated when viewed with the wireframe node. Inputs. This node has no inputs. Properties. Pixel size. When enabled, the size of edge lines is set in screen space. Size. Thickness of the edge lines. Outputs. Factor. Black and white mask showing white lines representing edges according to the object's topology. Example. This is all about input nodes. Thank you for watching. Subscribe Blender with KAL. Finished.